Hello, hi everyone. We go next lesson. Okay, next section for matrices. This one we're gonna learn about determinants of a square matrix. Okay, determinants for for 2 by 2 matrix. Everyone learned already from last year, right? When you was grade 10, when you were grade 10. So, but today we leave a little bit, but we can learn more a little bit for last year before we go to the application. Okay. So now see how to find the determinants of a 2 by 2 matrix. In every square matrix can be associated with a real number. Okay, so in general we can see most is in linear equation. Linear equation mean like x power 1 y power 1, right? For example, in linear equation we get used to on this pattern, correct? We have like a1 x plus b1 y equal to c1. Okay, and then a2 x plus b2 y equal to c2. Okay, in this case, if we want to find determinant of this one, in general, everyone know already how to write in the pattern of determinant, right? So, but before that, from this linear equation, okay, we have two equations here. So if we write as a matrix, in general, we write it down as a matrix A. We will get the coefficients, right? So we're gonna have A1, B1, A2, B2. Okay, so we like this matrix coefficients matrix. So this one is a coefficients matrix. Okay. So then if you want to find determinants from here, if you want to get determinants A, we like this determinant. Sometimes we like as the absolute. As the absolute A can be writing in both ways. Okay. So then this is a determinant. So then we get determinant, how we get it? From, we can do the cross multiplication, right? This time this minus this time this. So we're gonna have A1, B2, okay? A1 times B2 or B2 times A1 is okay. In general, we load it down as will be written as a order alphabet, okay? And then minus, the formula have to be minus A2 times B1. That's a determinant of 2 by 2. Okay. Then this one everyone know, and then we can go next. Maybe example. Just say example how. Right? So give one example. Just review this one. Okay, review. I think I'm sure everyone already know and recall how to do. So example. If I give this example, say find the determinant. Okay. Find determinant of, say, A equal to maybe 2 minus 3 minus 1, 2. Okay. This is A. So we get that A, or like the absolute A, equal to 2 times 2 minus 3 times 1. Okay, so become 4 minus become plus, so come out equal to 7. Okay, this is a determinant 2 by 2. Then we go next one. Okay, just say, can I say first? You will learn determinant, how to find the determinant of 2 by 2, 3 by 3, 4 by 4, and so on up to n by n. Okay, And the next one, you're gonna find minor and cofactor of the square matrix. And the last one, gonna find out the determinant of the square matrices. So we go to the next example. One is minors and cofactors. Minor and cofactor of the square matrix. What the meaning? See this. If matrix A is a square matrix, okay, this one have to be square matrix, okay. The minor M subscript ij of the entry A, this one should be subscript ij. In the determinant of the matrix obtained by the deleting the its low, I mean, this one should be its low and the jts column of A. The cofactor C subscript ij of the entry A subscript ij is this formula. Actually, this one formula to find the cofactors. Okay, this is a formula to find the cofactors. Let me write down in the box. Okay. Now come to see this. What the meaning of A subscript ij, and they give this one cofactors and the aij. Okay. So maybe we can see cofactors M mean minus C cofactor of the subscript ij. When we write it down, for example, like a Cij, right? I represent low. I represent low. Okay. This one I mean row, and J mean column. Okay. For example, if I say C1, 2 like this, right? So that means you lead here row, first row, and the second column. First row and second column. Okay. So that's the meaning. So, but we're going to see example. If minor, for example, if say M 2, 3 like this, for example. So gonna be second row and third column. Okay, and then matrix A, this one matrix A, how many order they have? 3 rows, 3 columns. So become 3 by 3. And 3 by 3, this is a square matrix, correct? Square matrix mean 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, 5 by 5 matrix, up to n times n matrix, because square matrix. Okay, now we can find the minor, find all the minors and cofactor of matrix A, which is equal to this one, each element inside or entries in the matrix, according here on the question. So now we can find how to get minor. Okay, so they say find all minors. Find all minors. That means you have to find every elements inside. But we may not work all. Okay, we work some, get the idea. Okay, so then, for example, that means like a disposition. This element 0. This element 0 mean this one mean A11. So right now see this. If we see elements, right, or entry is mean A's. Entry A sub I. So like a C A11 equal to 0. If A12 equal to what? First row, second column, first row, second column is equal to 2 here. And we read A, okay? And so on if A13 for entry A, okay? So if we read this one, we read what? First row, third column, equal to 1. Sometimes this A we can write as a M minor Mij of the entry A1. Okay, so Mij actually mean this one also, but we see this example. Okay, for example, if I want to get for the m, find the minor, that means we have to find minor m11, okay, m12, and a, just say find every term from there. So if we get from, for example, we get from we start from minor 11, okay. So minor 11 means first row, first column, okay. So from this one gonna be equal to first row, first column, right? So you cross it out here. First row, first column, so this is a common point right here. So become, you like as like a matrix, first row, first column. So you left minus 1, 2, 0, 1, okay. From here, first row, first column. So this one you get this one, negative 1, 2, 0, 1, okay. So then you get this, like it look like a determinant, okay. So after this you just use like a formula determinant, become negative 1 times 1, negative 1, become negative 1 times 1, minus 0 times 2, so equal to minus 1, okay. So then this is the M11, minor first row, first column. Then you have to find M12, M12. So you go first row and second column, first row, second column. So you left 3, 2, 4, 1. Okay. Now, first row, second column. So you have 3, 2, 4, 1. 3, 2, 4, 1. Then you do determinant, become 3 times 1 minus 2 times 4. So then this one gonna be 3 minus 8. So you left negative 5. So the minor of the first row, second column equal to negative 5. This is how to find minor. Okay, and then you can go on to get the M13, so you can get M13. Okay, do the same way, gonna be this one. If M13 first row, third column, correct? First row. Now I try this one. If M13 means first row, because 1, first row, and 3, third column. First row, third column. So you left 3 minus 1, 4, 0. Okay. First row, third column, right here. So you left this one, 3, 1, 4, 0. So then you do the same. Minus 1 times 4. So come out become 4. Okay, but minus become plus. So this is the M13. Minor of the first row and third column. Okay, now how we gonna get cofactor? And you keep doing, okay? After this one, you do next one, this one. Next one you get M. This is a first row finish, then you go second row, become M21, M22, M23, right? Okay, so do the same way. So M21, that means second row, first column. Second row, first column. Okay, so you left second row, first column, you left 2, 1, 0, 1, right? And do the same way, keep doing. And let you practice for that one. And after this, you can get what? Continue to get M, the third row. So you can get M31, M32, M33, do the same way. Okay, so like a M31, that's third row, first column, third row, first column. Okay, so I do the different color, maybe here. Third row here, first column. So you left inside here, 2, 1, negative 1, 2. So this is gonna be 2, 1, negative 1, 2. And then they do the same thing, use the determinant concept. So 2 times 2 become 4, minus, and negative 1 times 1 become negative 1. So you have 5. So M31 equal to 5, and then you go on, okay? Now we go to see how to get cofactors. Next one, find the cofactors. We know how to get minors already now, how to get the cofactors, okay? So find all the cofactors. Now, still remember the question of this one, Cij, right? Cij equal to minus 1 power I plus j times Mij. Okay, then we use the formula to get all the cofactors of this matrix. Then this matrix is 3 by 3. Okay, so then that means we have to find for solution. We have to get like a first one, C11. Okay, C11 means row 1, column 1. Okay, so row 1, column 1. Before the, up to the formula become minus 1, right? And then 1 plus 1. And then M, see, row 1, column 1, if I cross this one out, row 1, column 1, so I left this one correct, row 1, column 1, so I left this one, so I write this one down. So I write the yellow color here, become negative 1, 2, 0, 1. Okay, after this you simplify. Become 1 plus power 2, so even number, so become what? Positive, even number, right? So index come out with a plus sign. So index come out with a plus sign. So this one you time it up here. So this one do the like a matrix, right? I mean the determinant. So this one gonna be 1 times 1, right? Time 1, time 1, negative 1 times 1 become negative 1. And then this one minus 0 times 2 becomes 0. Okay, so this one gonna be minus 1. Okay, then go to C12. You have to find every row, every term. So row, this is a row 1. Now we work on row 1. So then next one, okay, if I use this one, C12. Okay, gonna be minus 1. Again, index is 1 plus 2. Okay, and then this one get cross it out, row 1, second column, row 1, second column. So we left 3, 2, 4, 1. 3, 2, 4, 1. Okay. Okay, row 1, first row, second column. I mean, first row, second column, 3, 2, 4, 1. Okay, now we simplify next. This one again, index odd number, so the sign should be minus outside there. So then you time, right? Cross on the diagonal line here. Use a determinant. So 3 times 1 become 3, minus 4 times 2 become 8. So what we have here? Minus become have 5. Okay, that's the one. So you keep doing until you have like a C13. Next gonna be this is the first row finish. Then you go second row, so become 2, 1, C22, C23, right? And go on until third row become C31, C32, and C33. Use the same idea by using this formula. using this formula. Okay. So this is a way how to get the cofactors. Use this formula. Okay. Now that's a way how to get cofactors. Maybe we try one more, okay, before we go next one. Let's see which one we should try. Maybe we try this one, right? C21, go the second row, right? This one equals C21, second row here. So second row, first column, second row. So you can try across it out. C21, okay. Second row, first column. Second row, first column. So we left what? Left 2, 1, 0, 1. Okay, left this one 2, 1, 0, 1. And the font here for the coefficient, the sign. So index gonna be 1 plus 3. Okay. So then 1 plus 3 is power 4. So the sign should come out with a plus sign. So the rest you just do this one diagonal, get the like a determinant method. So 2 times 1 become 2 minus 2 times 0 times 1 becomes 0. So this one we're gonna get 2. So cofactor of first row, third column become 4, not third row, first row, third column, first row, third column. So 2, 1, 0, 1. So why they have 4 here? Where I'm wrong. First row. Oh, sorry. This one we were on here. I wrote it wrong. This we were on this one. Okay, I wrote it wrong. Should be column. Second row first. Second row first column. Okay, second row first column. So this one index I change here should be 2 plus 1. So come out minus sign. Okay. So this one come out minus sign. So this one should be negative for answer. So cofactor of 2, 1, subscript 2, 1 equal to negative 2. Okay, and then you do the rest. So we go next example. Okay. Now next one is the determinant of the square matrix. Okay, square matrix just can get determinant. So see the definition here. If A is a square matrix, A square matrix of order 2 by 2 or greater. Greater mean can be 3 by 3, 4 by 4, 5 by 5, up to n by n. But when n become larger, this is like a really large order, right? So in this case, gonna take a lot of time to do if n very high. It's a high order. So this one gonna most of the time gonna use the computer to help. But in manual, in general, we do 2 by 2, 3 by 3, maximum maybe 4 by 4, or maybe do up to 5 by 5, but take a lot of time. Okay, and the rest very long to finish the question. So the determinants of A, okay, is the sum. Okay, is the sum of the entry in any row or column of the multiplied. The determinant of A is the sum of the entries in any row or column of A multiplied by their respective cofactors. For instance, this example, expanding along the first row. Okay, now this, the give example say it's the first row, what is gonna be? Okay, determinant. Okay, if the, let's see, this one, say in the determinant A1, remember we load it down as like absolute sign A, absolute, but we lead at the determinant, okay, and then we write it down as a det A. Okay, if we want to find determinant A, For the first row, so we're gonna have A11, C11, right? Plus for the first row, so A11, C11, A12, C12, and so on, okay? Plus C13, I mean, sorry, A13, C13, and plus until A1, because we do on first row, so A1N, C1N to the N term. Okay, this if we want on the first row, for example, and for applying the definition to find a determinant is called expanding by cofactors. Okay, now see example. Find the determinant of this one. So if we, according to this definition, we use the first law, right? So this is a 3 by 3, order is 3 by 3. So if you want to use the first law, so we, according this one, we use this first law. Can use any law, okay? But now if we were on the first row, so how to get? So A11 means first row, first column. So from here, I can write down, say, so A11 is the element of each entry, right, in the matrix A. So A11, the first row, first column, first row, first column, so A11 0. So A12 gonna be what? First row, second column, so equal to 2. And then A13 again, first row, third column, so equal to 1. Okay. First row, third column, so equal to 1 here. Okay, so that's represent A subscript ij. That's represent each element of entry of the each matrix. Okay, now C is a cofactors. We already know the formula, correct? So how we get, if we want to find determinant of this matrix, so we're gonna use the first law instead, this one, according definition, but we can use any law, don't forget. So now we work on first law. So then determinant A is equal to this one, right? A11, use this formula. A11, so A1 0, so you like 0. 0, not A. So 0 here. So 0, and then times C11, right? Times C11, we use the formula is what? If we, or you want to work separate, term by term, up to you. You can work like a C11 outside what's about, right? If otherwise you time inside. So C11, we have what? -1. C11 power ij, ij means 1 plus 1, correct? 1 plus 1 become 2. And then do the formula, okay? I wrote down here. Maybe write down here. Formula. Cij equal to -1 I plus j, the formula, okay? Mij. So use this formula for cofactors. Okay, so this one C11, so become 1 plus 1 become 2, and then minor of 1, minor of 1, so you leave 1, first row, first column, right? This one you time this one, correct? First row, so I get from here. First row, first column, so we left this one. So you have -1, 2, 0, 1, right? That's a first term, okay? That's the first term. This one means this one first term now. Now we plus code this one second term, A12, C12. So A12, first row, second column is 2. So you write it down 2 here. Maybe I write it down. Right now we go on here, okay? So we write 2 here, and now time cofactor formula become -1. It's a 1, 2, so become power 3, right? And then you write the determinant of this one. First row, second column. See this one, first row, second column. So you have 2, that's why I like 2 here. Okay, now first row, second column, we left this one, become 3, 2, 4, 1. Okay, first row, second column, so 3, 2, 4, 1 for the M minor. Okay, and then go next. If we do next plus, now do this third term here, A13, C13 plus. So A, sorry, A13, so first row, third column, first row here, third column is here. So this one is a common coefficient is 1. So like then now the formula cofactors minus 1, because it's a 1, 3, right? 1, 3, so power become 4 even number. And then you do the determinant sign. First row, third column, first row, third column. So we left 3 minus 1, 4, 0. So we have 3 minus 1, 4, 0. Okay. Now we finish off this one. No, next we simplify, right? This term, the whole thing, right? We can leave it the other way because times 0, so this one should be 0, correct? But now we see this term. This term, the blue color here become 2, right? And this one is power odd number, so come out should be negative. So this one should be negative. So I change right away. This one gonna be negative side here, and then determinant here. So 3, 1 times 3 become 3 minus 4 times 2 become 8. Okay, and next one plus this term. Again, this one power even number, so come out should be plus, so this one still plus. Now only this one gonna be what? Time 3 times 0, 0 minus minus become plus 4. So that then simplify. This one minus 5 times minus become plus 10, and this one plus 4. So we have 14. Okay. So then this you use the formula of the cofactors. If another way, I give you another way to find determinant of 3 by 3s. Okay. So I give you which one? This color maybe. Only this one, if you don't want to concern about the, or still concerned, but they have the trick on here. In this case, from this line, okay, from this one, this step. The first one still the same. Okay, when you like determinant here, I talk about here. Talk about determinant side here. Still the same. Okay. Only you have to change it right here. So I write down anyway. This one become 0 anyway. Okay. Still this one no swap. So be okay, like this. Just rewrite one more time. So this one gonna be 0 time inside here is a 1, right? Become plus. So you have negative 1. I write down here. I don't like this one because come 1 with a plus 1 anyway. So I like this one. Okay. Negative 1, 2, 0, 1. Negative 1, 2, 0, 1 here. And plus the second term here, because the second term is what? It's an odd, right? So every odd number you can do by like this one. When you have to follow this one. Okay. So this one to become negative 1 power 3. Okay. But then we determinant this one. If you use this one, we don't need to write the font here, the size. So let me erase this one first. We don't need the font here, okay? The minus 1 plus ij. Only this one, when you write determinant, I mean this part, okay, this part. When you write the second term here, you just, instead you're gonna write 3, 2, 4, 1, you swap become 2, 3, 1, 4. Okay, swap this position, swap, or swap it. Become 2, 3, 1, 4. Okay, and then plus this one. 1, right? 1 still there. And the determinant, this one did not change because the 1, 4 is an even number. So to keep the same, don't need to swap. Okay. So this like determinant sign. So you swap only the one with the here with the with the odd number. Okay, but this is an even number, odd number, even number. So you swap only this one. Okay, the odd number. That's why you swap this one. We different from here, correct? Only that's all. And the rest, first term, third term still keep the same. So for now, you just simplify. So this term still 0. And this term gonna be 2. This one is what 1, 4, right? So you time become 8. This 3 times 1 become minus 3, right? And then this one plus 1 time is the same. So 3 times 0, 0. And minus become plus 4. So you do the same, okay, everyone? And then what we left, this become 5, 5 times 2 become 10, plus 4 become 14. Okay, so understand. So now you see we have the same solution. Okay. So if you want to use this way to do the determinant 3 by 3, you just consider swap only the subscript is an odd number, swap, and the even number you keep the same. And then you don't need to consider the sign plus minus anymore because they will automatically change for you. Okay, but if you don't swap this, then you follow the formula of this one. This one follow this formula on this question, okay? On this pattern. Okay, now we go next determinants, how to get determinant of the square matrix. I have a few more way to do. So now I will explain to you now next. Okay, so see next example. Use the same matrix A, okay? Another one is we can use by, see this, I use this color maybe. Get from the diagonal from the left. You see this one from the left hand side on beside the diagonal on here. So you use this one time 0 times 1 times 1, 0 times negative 1 times 1 becomes 0, correct? And after this, you use the top element here above the diagonal. Okay. And from this two, right? From this one, we have 2 elements on the top, on the above of diagonal. So every time you must have 3 elements or 3 entries to time it up. Okay. So then from this diagonal have 2, right? So you 2 already, then cross time to the opposite side under here. Which one have one element alone? This one, correct? So then you time 2 times 2 times 4 become 16, and then the sign is a plus because plus. Now you see the top here, left 1 element here, right? So you go to time every terms in the left element and the bottom. So this is 1 element. So you time move 1 time this one. So 1 times 3 times 0. So equal to 0. So you time according the sign, and then each step just plus. Then you simplify, this one becomes 16. Now next, see on the top here. Now come to below. Now we'll come to this side or right hand side diagonal. This diagonal 4 negative 1 1, right? So this diagonal you time 4 times negative 1 times 1. We have negative 4. Okay. Now again on the bottom here, you see this element 0, 2 in this diagonal, right? 0, 2 have two elements. Then you have to time cross to the other side, which have only one element in the diagonal line. So 0, 2, can maybe I use another color, I think. Which one more clear? Pink. Okay, this one, right? Then we use this one 0, 2. This is a two element already, right? You time cross to the other side, we should have one element in the diagonal line, okay? So this is what? This one, right? Because have one element in diagonal line. So 0 times 2 times 0 become 0, correct? So this one plus 0. The first one minus 4, we already have diagonal. Then you left 1 on the bottom, 1, right? So this is one element diagonal. And then you time cross to the other side, which have two elements, make it 3 elements time to get together. So this is one element in diagonal. Then you time cross to this one, correct? Because this have two elements in the diagonal line. So become 1 times 2 times 3. 1 times 2 times 3 become 6. So you plus 6. Okay, then you sum it up. This one gonna be 2, right? After this, always get the below minus top. So you have 16 minus 2. So you have 14. Okay, so then you see the answer we got from previous method. See the last page. See, I have 14, this one 14. So I have this one also 14, the same way. Same answer, I mean, but different way. Okay, now I give you another method. Okay. I think this is more popular for this way. I think most students like this one. Okay, then use the same matrix here. So you just like as a determinant. 0, copy all the element down. 0, 3, -4. Okay, this -4. And then 2, -1, 0, 1, 2, 1. Correct? Do I wrote correct? 0, no negative, this one. This one 0, 3, 4, 2, -1, 0, 1, 2, 1. Yes. Now we start. So you like as the determinant sign. After this, you copy first column and second column by side of it. Like in the same line, exactly same location. So we won't make mistake after next step. So become 2, -1, and 0. Okay. After this, we do cross multiplication here. Again, this one diagonal line is only one element, leave it. A diagonal line here, 2 elements, leave it. So you start from 3 because 3 by 3. So then you times 4, -1 times 1 become -4. 0 times 2 times 0 become 0. This one -4. And then diagonal line here, 1 times 3 times 2 become 6. Okay. So after this, do the next step. If I have this one, then next one, sorry, come to the diagonal line again from this side. This is a one element, right? 4 diagonal one element. This 3 0, this 2 element, not enough. So we start from here, 3 elements on the diagonal line. So 0 times -1 times 1 becomes 0. And this diagonal line 2 times 2 times 4 become 16. So plus 16. And next 1 times 3 times 0. Sorry, 0. So become 0. So sum it up, this becomes 16. And the top here sum it up. Plus, right? So we have 2. Again, always get the bottom minus top. So you have 16 minus 2. So equal to 14. Okay, so now this equal, correct? So all equal. So you can select which way or which method is easy for you to use to get a determinant 3 by 3. Okay. So now next example. Now find determinant of the matrix A now become 4 by 4. 1, 2, 3, 4 row. 1, 2, 3, 4, 4 columns. So become 4 times 4. So now 4 by 4 now gonna be different from 3 by 3. And then if you do 5 by 5, still the same, gonna do a 4 by 4 by using cofactor and minor to help. Okay. So in this question, in this example, we can do by use find the determinant A. Use the in this case you consider first. You see which row or which column have more zero, so we pick that one. Otherwise, you're gonna do a lot of steps. So we pick the row or the column which is have most zeros. So you can observe right now the most zero is what? Column 3, right? So we have 0, 0 here. So we pick this one. So from this one, how we do it? Find determinant A. Okay. Again, you can use any row, any column you want, but right now we try to select the most zero to do. So we're gonna work on here. That means we're gonna get this row 1, third column, row 2, third column, row 3, third column, row 4, third column. Okay, so we can write down become A1. Use the formula previous one example, the definition. So row 1 that means A11 time first row, third column, so become first row, third column, so B1. No, this one should be 3 here. First row, third column, first row, third column, plus next gonna be this first row, third column, second row, third column, so gonna be 2, 3, plus C, 2, 3. Now gonna be third row, third column, so A, 3, 3, third row, third column, 3, 3, so C, 3, 3. Plus next one, fourth row, third column, fourth row, third column, so become C, 4. Fourth row, fourth column. Fourth row, fourth column. No, it's correct. Should be fourth row, third column, sorry. Fourth row, third column, and this one also, fourth row, third column. And this one, third row, third column, second row, third column, first row, third column, yes. Okay, so we have 4 terms. Now we can start to get this one. See, this one is a 1, 3, okay? So first row, third column is what? First row, you see that? I draw with color here. Right now, do A, okay? First row, third column, get the common, get A13, right? So this means this one. Okay, so you write down 3 times C13. We get the element term, the coefficient for the coefficients. So this one, second row, third column is 0, right? This one's a 0 times C23. Maybe I use different color, how about that? So this one becomes 0 times this one. Next, this one, I like this one. So easy to see. And then next one, plus third row, third column, also 0, so times C33. Okay, plus fourth row, third column, C also 0, so times C43. Okay, so now this one maybe I use this color because yellow color cannot see very well. C13 here. Okay, so now you see the second term, third term, fourth term here all equal to 0, correct? This equal to zero because 0 times the cofactor for 2, 3. So everything becomes 0. So this one equals 0. So our job only find what? The first one here. Find C13. First row, third column. So we're finding for this one. First row, third column. First row, third column. So again, we use the formula of this one again. Okay, don't forget this popular formula. This one, Cij equal to -1 power I plus j and Mij. Okay, so then we have this one gonna be -1 power 113, right? Become power 4, and then get this one, get the minor, right? So come back here. First row, third column. First row, third column. So we left here, right? Get -1, 1, 2, 0, 2, 3, 3, 4, 1. Write it down. So we write down become -1, 1, 2, 0, 2, 3, 3, 4, 3, 4, 2. Okay. Now after this one, no. And then see this, after we have this one minor here already, right? So next we find the next step, get the determinant of this one. So in this one become 3 by 3 determinant, remember? So you can use any method, and that's what I give you 4 ways to get, right? You pick which way is easy for you. So maybe I do this one, right? So from this one, I did not say equal yet, okay? So I use this way, determinant -1, 1, 2, 0, 2, 3, 3, 4, 2. I do this way, okay? I think this way faster. Then this one become write down the first column and second column by side here on the left, right on the left. 1, 2, 4. Now start to do this one. Diagonal 1 element, skip it. Second element, skip it. Diagonal 3, we do it. Become 3 times 2 become 4, 12, right? And then 4 times 3 times -1, 12 become -12. And then 2 times 0 times 1 become 0. And then this one plus it up. Plus, okay? This one plus. So become 0, correct? Now come back to the bottom one. One diagonal, one element, leave it. Second element, leave it. Now third, 3 element, start to do it. Become -4. And then this one, 1 times 3 become 9. And then this one, 2 times 0 times 4 become 0. Then sum it up. So become 5. Okay, so then always use the bottom minus top. So 5 minus 0 become 5. So we have this one equal to 5. But we need to find this, don't forget, because we have to times 3, this is a determinant. So the final determinant of matrix A equal to 3 times 5 here, equal to 15. So final answer for determinant of matrix A 4 by 4 equal to 15. Okay, so that's all for the determinant idea of the have to be square matrix. Can be do 2 by 2. 2 by 2 easy, everyone learn. You learned already last year. And 3 by 3, that's the way I give to you, 3 or 4 way. And if after 3 by 3, 4 by 4, 5 by 5, you have to use this one. Use the idea of cofactor and the minor to help. And you do step by step. If 5 by 5 more step to do. Again, don't forget, try to select the columns or any row with the small 0 element inside and start do from that one. Otherwise, you're going to do many terms to finish. So this question, so this example have 3 zero there, so still easy, right? Because you do only one here, one terms here, only one term, the first one. Okay, so I think that's all for today about the square matrix, determinant matrix, determinant of a square matrix. Okay, so see you next class. Okay, I'm gonna have some question that you do. Thank you. Bye bye.